Hello everyone. Welcome to your physics class of class 8. I hope you all will be fine. Students, in our previous video, we were discussing lesson number 5. Now today in this video, we will continue that lesson. Okay, so let's begin our class. Effects of reflection. First one is the depth of water in a vessel when seen from air appears to be less. Means when we see water in a vessel from air, it appears to be less. Consider a vessel containing water as shown in the figure 5.6. You can see here in this figure, the real depth of water is AO, but you can see here the real depth of water is AO, but it seems to be AI. Okay, now why this happens? Reason is that a ray of light OA from the point O at the bottom of this vessel incident normally at point A on the surface XY. This is known as water air surface. Now another ray OB incident from water surface XY. When it passes through the air, it slightly bends away from the normal. As you can see, it bends slightly away from the normal. It does not move straight, but it will move away from the normal, bends away from the normal, and goes along the path BC, as you can see here. Now when these two rays, reflected rays, are produced at the back, and they appears to meet at, when these reflected rays are produced backwards, it meets at I. So this is the image of O. Okay, this point O is the original position. So this is the image of this O. Thus, to the observer in air, the depth of vessel appears to be AI instead of AO. As you can see in this picture also, it will appear AI, not AO. The depth will appear AI due to the refraction of light from water to air. And why it happens? Because of the refraction of light from water to air. The apparent depth AI is less than the real depth. Okay. This is why the depth of the water in air when seen from the air appears to be less. Okay. Now, early sunrise and late sunset. Before sunrise and after sunset, the upper atmospheric layers are warmer than the layers near the Earth's surface. Means before sunrise and after sunset, the upper atmospheric layers are warmer than the layers near the, as compared to the layers near the Earth's surface. So the atmospheric layers near the Earth's surface are denser than the above, because they are cooler than the above air layer of the atmospheric layers. That's why it is denser than those above. When the sun is just below the horizon, the light from sun while coming towards the earth suffers reflection from a rarer to a denser layer, and so it bends towards a normal. As you know that when the light travels from rarer to denser medium, it bends towards a normal at each reflection. And due to continuous bending of light rays at different successive layers, the sun can be seen even when its actual position is just below the horizon. Okay, as you can see in this picture, the actual position of the sun is this, but it appears to be here. Okay, as a result, the sun is seen in advance a few minutes before it rises above the horizon in the morning. Similarly, in the evening, sun is seen delayed by 3 to 4 minutes longer above the horizon after the sunset. Okay, due to the reflection of light from the sun in the atmosphere. Now, mirage in a desert. Sometimes in deserts, an inverted image of a tree is seen which gives a false impression of water under the tree. This is called mirage. As you can see in this picture, it appears to be an inverted image of the tree. Okay, now why it happened? The cause of mirage is the refraction of light. In a desert, the sand becomes very hot during the day time, and it rapidly heats the layers of the air in contact with the ground. Okay, as the desert is very hot during the daytime, it heat up the layers near the of air in contact with it. Therefore, the layers of the air near the ground are warmer than the upper layers, In other words, the successive upper layers are denser as compared to those below them. And when a ray of light from the sun after reflection from the top of a tree travels to the denser layer of the denser to a rarer layer, it bends away from the normal. As you know that when a light ray refract from a denser to a rarer medium, it bends away from the normal, and as a result, in reflection at the surface of separation of successive layers, each time the angle of refraction increases and the angle of incident of ray going from denser to rarer medium also increases till a stage is reached when the angle of refraction becomes 90 degree, as you can see in this picture. Okay, this picture, this tree appears to be inverted. On further increase in angle of incidence, the ray of light traveling from a denser to a rarer medium in hot is not reflected, but it suffers reflection, and this reflected rays now travel from rarer to a denser medium, so it bends towards the normal at each refraction. On reaching the eyes of the observer, an inverted image of the tree is seen, and it gives a false impression of a pool of water in front of the tree. Okay, why? Because when the light rays from of the sun travels from rarer to denser medium, it bends towards the normal, and at each reflection, on reaching these rays, the angle of incidence and refraction increases, and therefore the tree appears to be inverted. Okay, so these are the refraction of light. These are the effects of reflection of light. Okay, so what you have to do, you have to read this lesson up to here, and further explanation of the lesson I will give you in the next video. Thank you.